Welcome to the Bentley Systems training course to learn how to optimize post-tensioned concrete slabs in RAM Concept Connect Edition. Over the next series of videos, you will learn how to model optimizable post-tensioned objects, perform an optimization, and review the results. Before we begin our optimization workflow, let's first discuss the traditional design process for post-tensioned concrete slabs and some of the advantages you can expect by utilizing an optimization workflow instead. Traditionally, post-tensioned concrete slabs are designed by manually defining a post-tensioning solution that satisfies the minimum pre-compression and maximum spacing requirements. You would then add strands until the flexural tension stress limits are satisfied. This can lead to a highly iterative and time-consuming process, resulting in a wide array of potential solutions, including different combinations for post-tensioning, rebar, and punching shear reinforcement. Since the traditional process can be tedious and time-consuming, engineers typically do not investigate many design alternatives, and as such, it is difficult to know how economical the final design is, considering the total cost of materials, labor, post-tensioning, rebar, and punching shear reinforcement. The post-tensioning optimization workflow in RAM Concept utilizes intelligent search algorithms to compare thousands of design alternatives. This will allow you to easily review and compare many different solutions side by side and select the best design for your situation. The optimization workflow will also weed out invalid trials that do not satisfy required code criteria, which eliminates the need for manual iteration, and it can save hours of engineering time. In this training course, which will be completed over the next series of videos, you will optimize the post-tensioning layout for an elevated slab that has already been created in RAM Concept. This is the first video in this series where we will familiarize ourselves with the sample model and review the RAM Concept post-tensioning layers. To start our workflow, we're going to launch RAM Concept using the icon on our desktop. Once the program opens, we're going to ensure that the post-tensioning license is selected, and then we'll go ahead and click OK. Once in RAM Concept, we can go ahead and launch our sample model that was supplied with this training. Now that our sample model has been opened, let's go ahead and review a few of the layers that have already been populated with information. And we're going to start with our mesh input layer. Now what you're going to notice is that all of our sample model geometry has already been defined. Our main concrete slab is a 12-inch thick concrete slab which has been placed at elevation of 0 inches. Over at the left-hand side of your screen, you're going to notice a 10-inch concrete slab depression which has been set down 2 inches from the top of slab for the main slab. In addition to that, all of our interior columns have an 18-inch thick concrete drop cap located at their centers, and we also have a fairly large slab opening. Now our goal for this training course over the next series of videos is to define our optimizable objects. Now RAM Concept can optimize post-tension concrete slabs for any tendon layout. For this particular model, we are going to be creating our tendon layout as follows. In the latitude direction, we are going to be optimizing a banded tendon layout, and for our longitude direction, we will be optimizing a distributed tendon layout. In addition to reviewing the mesh input plan, I also want to point your attention to the drawing input layer. On this layer, you're going to notice that all of our model geometry was created in a CAD file and then imported into RAM Concept. Within this CAD file, we have placed grid lines at all of our major column intersection locations, as well as at the half span locations. We will be using these grid lines for this training course to snap our optimizable objects to ensure that our model is created accurately. Now, this is an optional portion of the workflow. You don't necessarily need to create grid lines, but it will assist you in creating an accurate model and placing your objects exactly where you intended. Now, to turn on any information from a different layer, you can go to your Visible Objects icon, select the layer for which holds the objects, and select which objects you want to turn on. For this example, I'll turn on my grid lines and my construction grid lines on my mesh input plan. Now, with these objects, I can use my Snaps toolbar to snap to any grid locations or any objects or any of these other snap options if they are appropriate. The next set of layers we're going to take a look at is our design spans or design strip plans. Now, what you're going to notice is that the design strips have already been generated in both the latitude and longitude directions. Now, what's important when you're preparing your model for post-tensioning is to ensure that within the General tab, the Consider as Post-Tensioned checkbox is selected, which will instruct RAM Concept that this is a post-tension concrete slab. Now that we've reviewed our sample model, let's also take a few moments to discuss some of the post-tensioning layers that we have available in RAM Concept. For each direction, both latitude and longitude, we have 3 sets of layers. These include the latitude tendon parameters, the generated latitude tendon layers, and also the manual latitude tendon layers. Now, post-tension tendons in RAM Concept can be created by specifying objects on the tendon parameters layer, resulting in generated tendons on the generated tendon layer, or by drawing individual tendons directly on the manual tendon layer. When the calculation is performed, all tendons modeled on the generated and manual tendon layers will be considered. Now, if you are using the manual tendon layers, these layers will contain a manual layout of post-tensioning tendons and jacks for the structure. With this workflow, you would manually model the tendon layout, including specifically specifying each strand and profile point in each direction. The manual tendon layer is for specifically modeling your tendon layout and will not contain any optimizable objects. For that reason, we are going to be using the tendon parameter layers instead. Now, the tendon parameter layers contain high-level objects that are defined and used for the generation of individual tendons. This layer will facilitate the production quality presentation of high-level tendon layout information. Let's go ahead and navigate to the latitude tendon parameters standard plan. Now, within this plan, or in the longitude direction, you can create optimizable objects for your banded tendon polylines, your distributed tendon quadrilaterals, and all of your profile points. Since we are planning on performing an optimization for our post-tension concrete slab in RAM Concept, we will be modeling all of our post-tension objects on either the latitude tendon parameters plan or the longitude tendon parameters plans.
If you found this video helpful, please give it a like. If you want to see more such series, consider subscribing to our channel. Thank you, and see you next time.